From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm KaushikGopal.
Welcome to the show. Prior to my dive into Android development, I spent the majority of my time working in languages like .NET, Ruby, JavaScript, mainly web technologies. And one of the things that I loved about the language of C# was that they had this thing known as extension functions. And this to me was just phenomenal. Now, when I came over to Android, of course, we were in Java 5, 6 at the time, and we didn't have extension functions. And heck, we didn't have much of anything. Everything was a for loop. There was no, language integrated query. There were no, map, flat map. There was none of this stuff. It was just loops everywhere to do what you needed to do. Anyway, but the problem that I found is that every time I needed to do something special for a particular class I was working with, maybe the view class or customer class, and this could be something I wrote or maybe I'm the author of, or I have access to the source code, or it's something that's closed source that I don't have the ability to alter, such as maybe something in the Android framework, I would find myself creating a utils class. And I'm sure we've all done this. We've created a view utils, and you probably have one in your application now that might be legacy, or you still have one and still use it. And it has something like, view utils.hide or view utils.show. And you pass an instance of a view into it, and all it does is set the visibility property to visible or gone or invisible, whichever one you use. Now this works fine. This is something that's been very common inside of Java for many, many years. However, with the advent of Kotlin, we now have the ability to perform extension functions. And so for a lot of you listening, this is going to be kind of old hat. You've already done this. You're familiar with this. For some of you who haven't got into extension functions, you realize it's a very powerful feature. So let's take a simple example here of what is an extension function. And I'm going to kind of expand on the example I had before. We have a view class, and that view class inside of Android, we can actually hide the view or show the view. And I'm just going to go with the simple setting the visibility modifier to gone to get rid of the view. And if I want to show it, I set it to visible. This is something we've all done before. So view, set visibility, etc. We pass in the values. You've probably created a utils class, as I said before, for this. Now, what if we could just say I had like a text view? I said text view dot gone, and it just disappeared. What if I could do that? That would be really nice. The syntactic sugar of that would be fantastic. I could just read it. I know exactly what it's going to do. If I want to make it visible, I'd say text view dot visible, and that would be the instance variable. So maybe it's a customer's first name. I'd say first name dot gone, and it would just not be visible on the screen. And it's a first name dot visible, and it would show back up again. And all it's doing is really setting the visibility modifier on the view. Now you can do this in Kotlin. You can actually create an extension function. That's what an extension function is. It allows you to basically bolt on additional functionality without having to actually modify the existing source code or inherit from it or anything else like that. And this is known as an extension function. There's also extension properties too, but we're talking about extension functions right now. And so let's say you wanted to implement that .gone. How would you do that? So inside of a empty file, let's just use that example now so it's visible everywhere. I'd say, all right, I'd type a function called fun, and I'd say view, and that'd just be, again, Android's view, fun, view dot gone, and then open close parentheses, curly bracket. And then what I would say inside of there is that's where I would be able to now have an instance of that particular view with the word this. So inside of the function, when I'm using this is actually the handle to the view that I'm working with. So that view could be a text view, it could be a linear layout, it could be, something custom that you've made, anything. It's just going to be an instance of an Android view. And at that point, I can really do anything I want with it. But here I'm creating a method called gone. And now what I'll do is I'll say view dot, set visibility. I'll pass in the view dot, view.gone as the modifier there. And then that's it. At that point in time, I don't have to return anything. I am just now setting the visibility on this. So the fantastic thing about this is in Kotlin, if I open some other Kotlin file in my application, this could be a fragment, could be an activity, could be a view, another view, anything like that. It could be a presenter, whatever pattern you're using, and you have access to a view, and you have an instance of a view. I could say now view, just again, go with the text view, or let's actually use a linear layout. Let's say I have a linear layout that has a bunch of data in it for maybe our platinum customers. So it's only going to show if the user's platinum. I determine for whatever reason that they're not a platinum customer, so I need to hide the view so they don't see it. And then I'd say, all right, I have an instance of it, and it'd be, platinum info would be the name of my linear layout, which contains all my fancy, call to actions for all my platinum customers. But this person is not a platinum customer, so let's go ahead and hide this. What I would say is, platinum, view or whatever I call it in my instance variable dot gone. Now I could easily call that method something else, but let's say dot gone. And at that point in time, what would happen is the extension function would then be invoked. And you're going to see inside the IDE that when you type dot, you'll actually see the actual method. And it looks like it's bolted, looks like it's directly a part of the actual implementation of view. And so that's the extension function at work. It's actually taking that and bolting it onto the existing type, which is fantastic. Now, like I said before, if we look back at the extension function hide, this keyword that's inside the extension function is known as a receiver object. And so that's the one that's passed to before the dot in the function name. So remember, the function name was view.gone. So that view is the receiver object. So we have a view. So any method that's on a view inside of that extension function, I can do stuff with. Now, let's say for some reason you think gone is a terrible name of an extension function and you think it should just be hide. Like, okay, that's fine. You can do that. You can say, all right, I want it to be, I'll create that extension function fun view.hide, and then I'll set the visibility to gone. Now you can do the same thing. You create another extension function directly below that and just say fun view.visible. And this time you just set the view's visibility modifier to visible. And now what you have is an couple of extension functions you can use all over the place to help simplify your code. You don't have to type out the long view.invisible or view.gone or anything like that. You actually just say whatever your instance is, .gone, or whatever your instance is, .visible. And it will automatically turn those on and off. Now you can do this. You can add an extension function for any type that you would like. So this could be something that you're going to be like a customer class that maybe you've created. You can create an extension function for that. Maybe it's a third-party library that you're using and they have a particular object or class that you would like to have a nice little, slap something on there at the end. Now, typically what I find myself doing is figuring out like when should I use an extension function. There's a couple of use cases. One, I find myself repeating myself a couple of times, and my co-host here, Kaushik, actually has a pretty good rule of thumb. If he finds himself doing something 3 times, then he'll extract it. And I really like that type of mentality. So if it's done 3 times, all right, maybe we should pull that out into an extension function. Something else I also like to do is if for some reason I have a chunk of code, and inside that chunk of code, everything's reading really nicely, but then I have to perform this weird operation on perhaps an object, and it kind of blows out and to be a bunch of logic, I might just turn that into an extension function. So my actual block of code that's on the screen just reads very cleanly, and then I can actually see the extension function is being called. The nice thing is, again, using the tooling, you can actually navigate directly to the implementation and see what the implementation is. So the nice thing here is that this is super easy to do. You can get going with this pretty quickly. You can do a whole bunch of different things. If you want to test and play with it, you can just fire up, a Kotlin file and just try to add something to an existing class. Like I said, I recommend just going with the view one, starting with there. That's something that we all do fairly consistently. So here's a view, set it to gone, set it to visible. From there, you can start moving on to other objects as well. And then start doing that. Now, one of the things that you do have to be aware of is that you need to make sure that you organize your extensions accordingly. And what I mean by that is there's going to be times when you have your extensions. And if you have an application that's just kind of one module and it's in your app module, you may just create a package in there called extensions, and you'll put your extensions in there. What I recommend doing is creating a file for each particular type of extension. So if you're going to have view extensions, then you organize it into a file called viewextensions.kt, and all of your view extensions go inside of there. Now, if you have many types of view extensions, you have extensions for the base type view, you have extensions for text views, you have extensions for spinners, you have extensions for constraint layouts and all that stuff. I would actually, and there's a bunch of them, I would actually start breaking those into their own files as well. So I might have text view extensions.kt, I might have constraint layout extensions.kt, and each one of those are going to go inside of their own file. And then, of course, this can be inside of its own package. If I'm only using one module in my application, it will go inside of a package called extensions somewhere in my application. And then at that point, I can use them all over the place inside of my application. Now, however, a lot of applications are using multi-module implementations. So if you don't have that ability, then what I recommend is to have a module where you're having a bunch of your shared code already. So a lot of these times it's going to be like shared utilities or Android shared, or Android utils or something like that. Now, that's usually going to be shared across all of your modules because it has a bunch of nice utilities that you would like to use. Now, what I would do inside of there is create an extensions package inside of that shared module and put all of your shared extensions in there. And again, I would still organize them based upon their type. If you have a bunch of image view extensions, that should be an image view extensions.kt as well. And so the nice thing is you can use those extensions, and then they'll be inside of the files. They're easy to find, etc. And then you can use them. Now, they don't have to go directly in. These extensions don't have to go inside of a class declaration. You can just create a file, drop the extension function in there, and you're good to go. Which kind of brings me to the point of like, okay, well, let's assume that you have this multi-module approach, or you have a feature module or just a feature inside of your application. And you determine like, well, in this case, and when I'm working with a text view, in this environment, in this feature, I know that all my text views for whatever reason need to have a certain property set on them. They need to act a certain way, but it's only in this feature that this does this. We don't do this anywhere else in the app. We only do this in this feature. So in that case, what we usually do is we'll put the extensions inside of that package itself and just keep them with that application as well. Now you can also do certain things with like scoping of your extensions. And so you could just put it directly under a particular package. And then what I'll also do sometimes is if I know that I'm only going to be using an extension function inside of a class that's maybe a large class, but we're doing things over and over and over, and I need a few extension functions, I'll actually create a private extension function. So I'll just slap the word private in front of it. I'll drop the extension function directly inside of my file that I'm using. And then I can use the extension function and get that nice syntactic sugar inside that file itself. So again, this might be a particular feature. Again, that all my text views on this one screen may need to have these particular properties. I don't want to repeat myself 100 times, so I just create this quick little extension function, and I can say, hey, .foo, .bar, whatever, and it does something magical. And it's just really easy to keep in mind there. So again, you just want to make sure the goal here is just keep them organized, keep them within the scope of where you want to keep them. If there's something that should be shared all over, put them in a higher global, package level scope so you can use them all over the place, put them inside of a shared module, something like that. Put them inside of file names that match what they are. I don't recommend creating an extensions.kt file and then just like slamming 400 extensions in there. Like that's just bad, because if you need to go find out, well, hey, where is this extension function? What file is it located in? If you don't know the name of the actual file, or if you don't know the name of the extension, it's going to be real hard to find. But if you just keep it very simple with the type name and with the word extensions.kt, you can just use the go-to file navigation utility inside of Android Studio and navigate directly to the file, which is super easy to do. Now, the other thing that I would like to talk about is making sure that you don't go overboard. Sometimes folks will just go hog wild on creating extensions for every single thing that they see. And all of a sudden you're trying to follow the code path, and you see like, oh, there's 3 lines of code here, and this kind of the screen draws itself like, cool, how did that happen? And you go into this one, function, and it's an extension function, and it calls into some other extension function, which calls into some other extension function. Before you know it, you're like 14 layers deep in extension functions, and someone's just setting, determining if a value is even or odd. And then you walk back up and you determine if it's odd, then it's red. Then if it's even, the color's blue. And then you go further up, and you kind of see what I'm saying. It's just like a complete nightmare. So you want to make sure you don't go overboard on these things. It should make your job easier. They should be very useful. But if you find yourself nesting multiple calls into extension functions, you might want to rethink like, all right, am I doing this properly? Did I compose everything correctly? Maybe I need to rethink the design of my app, or maybe this implementation to make this a little bit easier to follow, because you can get to kind of an extension function explosion. And then it actually starts to kind of turn into some spaghetti code real fast. So just be careful of that and just kind of look out to see, ask yourself, is this getting more confusing? Do I need to do this or not? One of the things that I do really want to point out to make very clear here is that extension functions do not actually modify the classes they extend, so they don't change anything. The extensions are actually resolved statically. So what that means is when you define an extension function, you're not actually inserting new code into the existing class. You're not inserting new members or functions or anything like that. You're just making new function calls available with the dot notation on variables of that type. Now, what that means is underneath the hood, you actually have a class that's created. So let's just say we have view extensions, right? And that's going to be my view extensions.kt file. Now, the equivalent Java code, and this is kind of pseudocode here, would be view extensions kt would be the class name, because that's how everything's going to be compiled. And then inside of there, you're going to notice that the extension functions are actually resolved statically. So again, this is very clearly pointed out in the extension functions documentation on kotlinlang.org. So what this means is, if we were to look at this in Java, we'd have class view extensions kt, that would be the class. And inside there, we have a public static, probably public static void gone. And if we're using for view, it would take in an implementation of the view, or an instance of a view. And then inside that method, we would be basically calling the view set visibility gone, etc. Same thing for the visible one. Now, if we were to use that inside, if you wanted to use this inside of your application in Java, so you have some Java code lying around, you want to call this extension function, you're going to hit dot in your IDE, and you're going to notice it doesn't come up. Well, why is that? Because, well, Kotlin allows us to have that nice syntactical sugar inside the IDE, and the compiler is able to figure that out, saying, hey, anytime they call dot gone, what we're actually going to do is replace that kind of code with this similar code that does the static implementation. So we're not doing code replace, but there's some magic happening behind the scenes that makes it possible. Now, if I do want to call that from Java, it is possible, but it's going to be very similar to how we've been doing it for ages, such as the view utils, or whatever that we've had lying around in our applications. And but the thing is the name of that file though is going to be view extensions kt. And so if I wanted to use that, I would say view extensions kt.gone. I would pass in the instance of my view, and at that point the view would disappear. Now this is probably exactly the same as your view utils class that you have lying around somewhere, but actually having that view extensions kt is kind of ugly. Now I know that all of us cannot get rid of all of our Java right now inside of our application. It's just simply not feasible. There's too many legacy apps that just work. There's no need to rewrite it if you don't need to rewrite it, but sometimes you do need access to that new fancy stuff in Kotlin. So thankfully, one of the things that you can do is actually tell the JVM that you would like the file name to be different. So in this case, instead of it being view extensions kt, which is would be the name of the file in the class, what I could actually say is, all right, look, I want you to actually call this view utils. And then inside of my Java my Java files, I could actually just say view utils.gone, pass in the name of my view or my instance of my view, and it handles it for me. Now this allows me to actually keep everything inside of, inside of my view extensions.kt file, the actual physical file on the disk, but then tell the compiler, hey, when everything's getting compiled, go ahead and inside of Java, and if we're calling it from there, just go ahead and call it view utils so I can access it easier that way, and it makes more idiomatic sense. So again, those are, if you're interested, check out JVM name inside of the Kotlin documentation if you're going to want to call this stuff from Kotlin. If you want to call this from Java. There are a bunch of other things that we could talk about here, but I'm not going to keep rambling on. You could talk about nullable receivers, how you can check for nulls inside of nullable types with extension functions, which is pretty awesome. That's pretty simple to do, just checking for null. It's actually what the toString method in Kotlin does on the any type. You can have extension properties, which allow you to have slap-on properties to existing classes, which is pretty cool. You want to check that out. You have companion object extensions, etc. You can declare extensions as members. So there's a couple of different things you want to get into, visibility and so forth. Now, if you want to check that out, we'll add the link to the show notes. It'll link you directly to the Kotlin Lang documentation for extension functions. So be sure to check that out, and we hope that it helps. And until next time.
That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.